Hello friends, welcome to Learners Forum. So this video is about the next arithmetic operation, which is multiplication. Let us see for the binary type now, and later we can see it for octal and hexadecimal type. So first example is taken as 110 and 10 given as two binary numbers. We have to do multiplication for this particular binary numbers. So starting is, we have to choose the rightmost bit. So 0 into 0 will be 0, 0 into 1 will be 0, 0 into 1 will be 0. So to proceed into the next bit, we have to make sure that we are shifting it to the right by 1 bit. So we take a cross mark here. Next 1 into 0 will be 0, 1 into 1 will be 1, again 1 into 1 will be 1. Now we have to add this particular bits starting from the rightmost one. So we have 0, 0 plus 0, 0, 0 plus 1, 1 and 1. So 1, 1, 0, 0 to the base 2 will be the answer after performing multiplication. Now let us see one more example for the similar type. So for the second example, let us take it as 1, 0, 1, 1, 1, 1, 0, 1, 1, 0 and 1, 1, 0. So let us multiply these two bits now, starting from the rightmost bit. So 0 into anything will be 0. So we will get the same value for the first line, which is 1, 0, 0, 0, 0, 0. Next, to perform the next line, we have to shift. So we take a cross mark in the last bit and now repeat the same procedure. So 1 multiplied with 0 will be 0. 1 into 1 will be 1. 1 into 1, 1. 1 into 0, 0. 1 into 1, 1. Next, we have one more bit. So we have to shift it by 2 bits now. So 2 cross marks are taken here. Next, 1 into 0, 0. 1 into 1, 1. 1 into 1, 1. 1 into 0, 0 and 1 into 1, 1. Now we have to perform addition for these 3 bits. So first is 0. Second, 0 plus 0 will be 0. 0 plus 1 will be 1. Now 1 plus 1 will be 2. Whenever we have the value as equivalent to base value or greater than base, we have to take it in CBR form like we have seen in the binary addition. So base is 2 here, so it is taken here. So we have got the result as 2. So we have to choose the carry value first. So whenever the value of base is equal or exceeding, we have to perform the same step, that is CBR. So now in place of carry, we can take the value as 1. So that 1 into 2 will be 2. That is the result. So we will not have anything in remainder, so 0. So here you can make a small mistake where you can take the value of carry as 0 and fill in the remainder value as 2, which will make carry 0 and remainder 2. Still we will get the same result. But every time we have to complete the carry into base first and then only we have to move into the remainder portion. So we will get carry as 1 and remainder as 0. We will get the result as 2. So the carry value is 1 and remainder is 0. We have to fill those values here. Carry as 1 and remainder is 0. So carry is 1 here. Next, performing the same step, 1 plus 1 will be 2. For 2, we will have the CBR values in the same way. So remainder 0 and carry is 1. Again 1 plus 1 is 2. So 2 has the CBR result. So remainder 0, carry 1. Again 1 plus 1 will be 2. Remainder 0, carry is 1. So this is the answer after performing binary multiplication. So the same procedure will be there for octal and hexadecimal with a simple change, that is the base value will be getting changed. Other than that, we will have the same procedure. Let us see it for octal type now. So the first example for octal is 127 multiplied by 23. So the base is 8 here. So starting from the rightmost bit, which is 3 into 7, 21. 21 is greater than the base value 8. So we have to do CBR now. Base is 8. So we will take the value of C as 2. So 2 into 8 will be 16 and remainder will be taken under the R value, which is 5. So we will get the result as 21. So remainder 5 here and carry 2 to the next bit. Next, 3 2s are 6. 6 plus 2 will be 8. 8 is again equal to the base value. So again we have to do CBR. So 1 into 8 will be 8 plus 0. So the value of remainder 0, carry is 1. Next, 3 into 1 will be 3 plus 1 is 4, which is less than 8. So we can write it as such 4. Next, we have to shift the position by 1 bit now. Then perform the same operation. 2 sevens are 14. So 14 can be represented as 8 into 1 and remaining value as 6 to the remainder. So remainder 6 here and 1 will be taken to the next bit. Next, 2 2s are 4. 4 plus 1 will be 5, which is less than 8. So we can write it as such. Next, last bit 2 into 1, which is 2. So now we have to add these two. So 5, 0 plus 6, 6, 5 plus 4 is 9. Again, 9 is greater than the base value, which is 8. So we have to perform CBR, which is equal to into 8. In the sense, we have to take carry as 1. 8 plus 1 is 9. So remainder is 1. So carry and remainder is filled here. And 1 plus 2 will be 3. So 3165 to the base 8 will be the answer for this octal multiplication. Let us solve one more example for better understanding. So the second example will be 5, 6, 7 multiplied by 36. So let us start from the first bit. 6 sevens are 42, which is greater than 8. So expressing it in CBR, base is 8 here. So 8 5s are 40. We can get the value of C as 5. 40 plus 2 will be 42. So remainder 2. So write the value of 2 here and carry is taken here. Next, 6 6 are 36. 36 plus 5 will be 41. Again, base value 8. So we can take 8 5s are 40 plus 1, which is taken to the remainder part. So 1 here and carry value is 5. So it is taken here. Next, 6 5s are 30. 30 plus 5 will be 35. So 4 into 8 will be 32 plus remaining 3 is taken under remainder. So 3 here and the carry value 4 is taken here. So the first step is over. Next we have to shift by one position. So cross mark. Next 3 sevens are 21. 21 is greater than 8. So 2 into 8 will be 16 plus remaining 5 is taken under the remainder value. So 5 here and value of carry 2 we can take to the next bit. Next 3 6 are 18. 18 plus 2 will be 20. So in CBR it is 2 into 8, which is 16 plus remaining 4 to the remainder value. So we will get 4 here and carry value 2 to the next bit, which can be written here. Next 3 5s are 15. 15 plus 2 will be 17. Expressing in CBR, we will get 2 into 8, which is 16 plus remaining 1 under remainder. So 1 and the carry value 2 is written in front. So we will just add these two bits now. 2, 6, 7, 5 and 2. So 2, 5, 7, 6, 2 will be the equivalent. Now let us perform the third type, which is hexadecimal multiplication. So here just the base value will be getting default, which is 16. So before starting out with the example, we have to know the values from A to F. So only with that we can fill in the values. So for A, B, C, D, E and F, the corresponding values will be 10, 11, 12, 13, 14 and 15. Now we can pick up the values easily. So the first example will be A, B, C multiplied by 23 to the base 16. Now let us do the same procedure. So the value of A, B, C can be picked up from here. So the value of A is 10. We can just write it in bottom. B is 11. C is 12. So first 3 into 12 will be 36. 36 is greater than the base value, which is 16. So 36 can be represented as, in CBR, base is 16. So 16 twos are 32. So under carry we can get 2 and the remaining 32 plus 4. So remainder will have the value as 4. So write the 4 value here and carry 2 to the next one. Next 3 into 11 will be 33. 33 plus 2 will be 35. So again applying CBR, it is 2 into 16 plus 3. So the remainder value is 3 and carry value is 2. Next 3 into 10 will be 30. 30 plus 2 is 32. So 32 can be written as 2 into 16, which is 32, plus remainder 0. So remainder 0 and carry is 2, which is written here. Next repeating the same bit for the next value, but we have to shift it by one position. So cross mark. Next 2 into 12 will be 24, which is greater than 16. So 1 into 16, 16, remaining 8, we can take it to the remainder part. So 8. So 8 is written here and carry 1 is taken to the next bit. Next 2 into 11 will be 22. 22 plus 1 will be 23. So writing it in CBR, 23 is 1 into 16 plus remaining 7. In the remainder will be taken. So 7 can be written here and the carry 1 is taken to the next bit. Next 2 into 10 will be 20. 20 plus 1 is 21. So 21 can be represented as 1 into 16 plus remainder 5. So 5 is written here and 1 is written in front since we don't have anything. Now perform addition. 4, 8 plus 3 is 11. 11 is represented as letter B. 0 plus 7 is 7. 5 plus 2 is 7 and 1. So 177B4 to the base 16 will be the answer after performing hexadecimal multiplication. This is the procedure to perform multiplication for any type like binary, octal and hexadecimal.